Algebra 2, we are going to be in lesson 14, and we're going to start actually by doing an equation of a line through 2 points, and you're going to find this problem on 14.1 on page 78. And so far we have looked at the equation y equals mx plus b. We know that b is where it intercepts the y, and the x is the rise over run. Okay, and that's all great. We've learned that. That's pretty simple to digest. However, one of the things that we are going to do with this is we're going to graph the points, and then we're going to actually establish what the slope is and solve the equation. So it's a little more complicated than just drawing the line or graphing the line, or getting the equation and solving for y and then graphing it. We are actually going to take the coordinates and actually create the equation. So in 14.1 it says find the equation of a line that passes through -3, 2, 3, -3. So we're going to start by actually graphing these points. So let's start with this one. Okay, -3 on the x-axis and up 2 gives us that point, and then this one is a positive 3x and a negative 3x, so it's going to be here. I'm going to try to do this as best I can to get this as straight as I can. Okay, pretty close. Alright, so now comes the question, how do we put it into context? How do we actually put it into the y equals mx plus b scenario? Alright, I'm going to use a trick of the trade, and where this point, if I draw a triangle, and where this point comes, I have created my slope. Okay, it's where it crosses over on those spots exactly. Okay, which means I have 1, 2, 3, 4, 5. I've got 5 units here, and down here I have 6 units. In other words, my rise is 5, my run is 6. So y equals 5 over 6 plus b. Well, what is b? Ooh, the problem is that b doesn't cross over on one of the intersections. It's like in between one. So we could estimate and say like, well, plus 1/2 or something like that. But we need to actually come up with a definite exact point for b. How do we do that? And by the way, don't forget the sign and to put x here. The sign, let's talk about that first. We're going from left to right, we're going downhill, so it's going to be negative, right? Alright, how do we find b? How do we find this number? Well, we're going to use our coordinates to substitute in this equation. If -3 is our x coordinate and 2 is our y coordinate, we can substitute y here, we can substitute x here. So we can say 2 equals -5 over 6 times -3 equals b. In other words, our y-intercept. We're after this point. We want to know what that point equals. Alright, how do we do this? Well, 2 equals, and then -3 times a -5 is 15 over 6 equals b. We have to give, because we're dealing with fractions here, we have to give 2 a fraction. Okay, how do we make 2 a fraction and with a denominator of 6? Well, we can change 2 and make 12 over 6, because 12 over 6 does equal 2, equals 15 over 6 equals b. Sorry, this should say, yeah. So now we have to have b, I'm sorry, this is plus b, not equals b. Okay, so what we have to do is we have to get b by itself. So we're going to subtract 15 over 6 here. We're going to subtract 15 over 6 here. And we can come up with our answer, all right? Which means that 12 minus 15, or 15 over 6 minus 12, is 3 over 6. But it's negative, okay? Because 15 minus 12, and this negative here is part of that, okay? So negative 3 over 6, which actually means that b is equal to a negative 1/2. So we can find it. We can also use this set if we wanted to. I'm not going to use that because we've already solved. It doesn't matter which set you use because it's the same, it's on the same line. These 2 points are on the same line. So you can use 3, negative 3, okay, or the negative 3 and 2. You can choose to use that either way, okay? So this is a really kind of difficult concept if you don't understand how to do this. Let's look at the example that they give us in your text, and I think in your textbook we're going to see this on number 16. Okay, 16, page 80, and it says find the equation of the line that passes through negative 3 and 4 and 3, negative 2. First things first, let's establish our quadrants. Okay, let's mark these. Negative 3 and 4. 1, 2, 3, 4. And then 3. 1, 2, 3, negative 2. So it looks a lot like the one we just did. Okay, so you can see, is this exactly half? No. And maybe it's going to get close to that, but we have to actually do the equation. So how are we going to start? Okay, remember, always start by doing your rise over run. Okay, rise is 1, 2, 3, 4, 5, 6, so it's 6. 1 is 1, 2, 3, 4, 5, 6, so it's 6 over 6, or 1. So y equals, and it's negative because it's going that direction, negative 1x plus b. We don't know what b is yet. We don't know where this point is. So we're going to have to use these coordinates to substitute. All right. So we're going to take 4 and substitute for y. We're going to take negative 3 and substitute for x. So now our equation looks like 4 equals negative 1 times negative 3 plus b. Okay, which means that 4 equals, and then negative 1 times negative 3 is a positive 3 plus b. We can subtract 3, we can subtract 3, so 1, or b, equals 1. So we can say y equals negative 1x plus 1. We just found the equation of our line. Okay? Now you're like, wait, that didn't cross over 1 right there. Well, probably because I didn't draw the line straight enough, and if I had, we would have seen that it would have been on 1. Anyway, doesn't matter. Whether you draw it right or not, even if you had a ruler and it didn't line up correctly, this has to be, because of the rise over run and your calculation of using this, it has to be correct. Okay, so that's the answer to number 16, and these are the types of problems that you are going to find from now on.